Going on to the PowerPoint slides now of Section 5 of Chapter 9, Natural Logarithms and Changing Bases. The base E and natural logarithms, changing logarithmic bases, and then graphs of exponential and logarithmic functions, base E. The base E and natural logarithms. Well, in our textbook presentation, we showed you how they get this irrational number E. And it's used in many applications and is usually present on your calculators. Changing logarithmic bases. Most calculators can find both common logarithms. This would be where we have base 10, and natural logarithms where we have base E. To find a logarithm with some other base, a conversion formula is usually needed. And this is the formula. Now they show how it is derived in our textbook lesson. And if you go to the textbook, they show step by step. Now the key in using this, and this should be copied into your notes, is to designate what is A, what is B, and what is M. So if we know what these letters are, A, B, and M, we just put it in this formula, and basically, as I showed in the other, is that a shortcut would be log of M divided by log of B. So if you know what M and B are, you just divide by those two. And this is what they'll tell you in the example. And this is the change of base formula. Again, write this down and this information. So if we were to do this, what will B and M be? Well, it's going to be 7 log of 7 divided by log of 3. Put that in your calculator, and then you're going to round to 4 decimal places. So our M is 7, and our B is 3. So it's log of 7 divided by log of 3, which you don't get these. You just plug it in and hit enter, and you get the answer, which is this, rounded to 4 decimal places. Now we'll be practicing this in our supplemental additional exercises. All right, graphs of exponential and logarithmic functions and base E. Now, for most of these, for those that don't have a calculator, a graphing calculator, you're going to just have to copy what you see here down. So there's a little table in which we put values for, this would be our Y, this is our X, and E we have in our calculator. Raise it to the 0 power, and anything to the 0 power is going to be 1. So 1 plus 1 is 2. So there's our first point. And then we graph these others, and we get this. And again, take time, make a little sketch of it using this formula up here. Now, here is the inverse of it. And all that the inverse does, again, if you put points in a t-chart, you get the reflection of this, keeping in mind, in a sense, the axis of symmetry is your y-axis, and that would be, let's put that correctly here, x equals 0. If x equals 0, that's the y-axis, and then it's reflected. So anytime you have its inverse, which is this line, or its exponential form, which is this line, it's the reflection of it along the axis of symmetry, which is your y-axis, or x equals 0. And here's another that they want you to graph. Notice when plus 1 is inside the parenthesis, it's going to shift that over to a negative 1, as you will see here. These are some points. And notice it's shifting it over to the negative 1. It doesn't quite ever reach it, even though it shows like it does. It doesn't. And let's just review what our domain and range will be of these. So what will our domain be? Well, it's going to start just beyond negative 1. So we use a parenthesis because negative 1 is not included, and it goes to positive infinity. And how about our range? Well, it's coming up from negative infinity, and eventually will go to positive infinity. And that's it. Kind of a short lesson. Our next video will be the additional exercises.